Hello, I'm Past Paper Guy. In this video I'm going to be solving the AQA A-Level Physics Specimen paper from 2014. This is the paper 2. You can see my other videos for the other papers. Now, the way I'm going to be doing it is I'm going to be doing it as you would have to do it in an exam, so I'm going to actually be writing on the paper and drawing on the paper and showing you how all the calculations work. And as I go along I'm going to be explaining it as well. The best way to use these videos, I think, is to go to the links below, make sure that you've printed off the paper yourself, given it a go yourself, and then have a look at these solutions for anything that you couldn't do. If you have any questions, please post them in the comments below, and I'll try and respond to them as quickly as I can. Okay, so without further ado, we'll start with question 1. Right, question 1, section A. We have a system that separates two minerals of ore using an electric field. So there's essentially a capacitor here with a potential across it, and some of these particles will be charged positively, so will be repelled from this side, some will be charged negatively, so will be attracted to this side, and they'll fall into these two different collectors. The crushed particles are of two different minerals going opposite charges as they go through the conveyor. When they leave the hopper, they fall 4.5 metre between the two parallel plates, which are 0.35 metre apart. Assume the particles have zero velocity when it leaves the hopper here and enters the region between the plates. Calculate the time taken for particles to fall between the plates. So this question here is a SUVAT question. Now, you're going to get asked a lot of questions like this which combine different things, so we're going to have electrical fields and SUVAT all in the same question. So we just need one of our SUVAT equations. So you write out SUVAT like that. S, the displacement, is 4.5 meters. U, it tells us that it starts off zero velocity, so that's 0. V, we don't really care about. A, we need to know, it's just falling under gravity, so it's 9.81. And T is what we're trying to find out there. So we look at our SUVAT, equations, and we need one that doesn't have V in it, so that one will do nicely. So S equals UT plus a half AT squared. And we're solving for T, that's 0, so we have T squared is equal to 2S over A, so we have T is equal to the square root of 2 times by S is 4.5, divided by A is 9.81. Okay, that's square root is the whole thing there. So turn the calculator on, and we have 2 times by 4.5 divided by 9.81. That gives us that, and we're going to square root that answer, which gives us that value there. So just under a second. So T is equal to 0.9578. So that's 2 sig fig, that's 2 sig fig, so we want it to 2 sig fig, so 0.96 seconds to 2 sig fig. Part 2, a potential difference of 65 kV, so that's 65,000 volts, is between the plates. Show that when the particle of specific charge 1.2 times 10 to the minus 6 coulombs per kilogram is between the plates, its horizontal acceleration is about 0.2 meters per second squared. Okay, so we know that the force on a charged particle inside an electric field is given by, just find it on the equation sheet here, the strength of the electric field times by the charge on the particle. Okay. We also know that the resultant force on something is equal to mass times by acceleration. That's Newton's second law. So if we rearrange that, then we get acceleration is equal to the electric field strength times by the charge on the particle divided by the mass. Now look at that there, coulombs per kilogram, that is the specific charge there. We need to know what the electric field strength is. Well, it's a parallel plate capacitor. So the electric field strength for a uniform field is given by V over D. So E is equal to V divided by D, so that's equal to 65,000 divided by the distance between the two plates, which is there, 0.35. So let's do that. 65,000 divided by 0.35 is going to be equal to 185.714 times 10 to the 3, and that's volts per meter, or newtons per kilogram. Newtons per coulomb. And then what we need to do is to substitute that value there into this here. So we have the acceleration is equal to 185.714 times 10 to the 3 times by, then we need that value there, which is that value there. So that's 1.2 times 10 to the minus 6. So times by 1.2 times 10 to the minus 6 is equal to 0.22. So A is equal to 0.223 meters per second squared. And it's a show that question, so that we've got to write it to more decimal places than that, which we have done. Right, part 3. Calculate the total horizontal deflection of the particle that occurs when it's falling between the plates. So this is another SUVET question, and we're doing it horizontal this time. So the distance is what we're trying to find out. The initial velocity horizontally is 0. We don't care about the final velocity. The acceleration we've just worked out is 0.22, it was 28, wasn't it? 28. And the time it has between the plates is the time we calculated back here. So that's 0.9578. We're going to need the same equation because we don't care about V, so it's S equals ut plus a half a t squared. So S is equal to 0 plus a half times by 0.223 times by 2228, I'll put, times by 0.9578. So we got 0.5 times 0.2228 and then times by 0.9578. Gives us this distance, so that's equal to 0.10669 ... we want it to 2 sig figs, so it's going to be 0.11 meter to 2 SF. Explain why the time taken to fall vertically between the plates is independent of the mass of the particle. So this is explain why all objects fall at the same rate, and they do so if you ignore air resistance. So any two objects will fall at the same rate if you ignore air resistance. So what we're basically doing here is we're showing how if we combine Newton's second law with the force of weight, mass will cancel out. So because the acceleration force, that's the weight, is mg, is proportional to the mass, so by Newton's second law, F is equal to ma which is equal to mg, the m's cancel, so A is equal to G, which is independent of mass. Okay, so what I think you need to do to answer this question is you need to invoke Newton's second law there. You need to show this piece of working here, and then you need to state what that means, so it's independent of mass. Okay. State and explain 2 reasons why the horizontal acceleration of the particle is different for each particle. Okay, so if we go back to here, the acceleration was equal to the electric field strength times by the charge mass ratio, the specific charge of a particle, so Q divided by M. So we need to state and explain 2 reasons why it could be different for each particle. Well, this is fixed because we're not changing the voltage here and we're not changing the distance between the 2 plates. So that's fixed. So there's 2 things left and we need 2 reasons. So one of them is going to be if this changes and one of them is going to be if that changes. Okay, so reason 1 is the mass of different particles may be different. What would happen, we need to explain here, so we need to link it to some physics. So we've said that it's this one. If the mass increases, the acceleration will decrease. So if the mass is bigger, acceleration is smaller. Okay, reason 2, well, that's that one, charge. So the charge may be different. And then what happens if charge is increased, then the acceleration will increase in this time because it's on the top. So if Q is bigger, then the acceleration will be bigger. 2. Okay, sorry, my bad writing there. So, how do you answer a question like this? Well, if you can find the equation that it relates to here, just look for what's constant and what's changing. So these 2 things could potentially change. That is definitely constant. So that cannot affect the acceleration. These 2 can. You need 2 reasons, 1 reason, 2 reasons. There we go. So that's the end of question 1.